Hi guys, Ariana here, and today we're going to be doing some more programming. The DodgeGame has really been bothering me quite a bit. You can see here, there's a frame rate counter in the top left, and my monitor has a really high frame rate, and so it makes it extremely hard to play when it's on such a high rate, because it's very, very difficult to dodge the pieces that are moving when they go like over twice as fast as 60 FPS. Maybe you can find a good spot to hang out, but yeah, so I wanted to fix that up just because it's been bothering me. So the way we're going to fix that up is in the update loop. So currently, update gets called essentially every frame by the browser and the game engine. So what we want to do is we want to limit this by tracking how much time has passed. So we're going to want something like accumulated time, something like that. So let's go ahead and make an accumulated time variable. All right, so then gonna go ahead and add the delta each time. And then if our accumulated time is greater than our target frame rate, then we actually want to do our update. And what we're going to want to do is pass in so then we're going to do like we're going to do this not accumulated time minus the target frame rate. And then we're going to pass in the target frame rate for the delta here to each of these things. And I think that might get us where we want. Let's call it target frame time actually. And let's aim for like 60 FPS. Okay, so I think that might do what we want. Yeah, you can see things are moving much slower now. So it's actually much easier to play. I feel like it might even be moving slower than I expected it to be, but maybe not. This is probably a good... maybe this is a good speed, because you can actually... I feel like at this speed you can actually dodge things. So yeah, there we go. Let's play again. So you can see the FPS counter up there is still based on the actual frame rate, but since we're only updating every at the 60 FPS frame time. That's why it moves slower. I feel like it looks a little laggy sometimes, but I don't know if that's just on my my monitor being such higher frame rate. I don't know. I think it's probably fine. Yeah, it feels like it's not quite smooth, but at least it's not going like a mile a minute, right? All right, let's see what kind of score I can get. Yeah, I'm getting like the same score I got when I first made it, so I guess that's probably about the speed we had it running back then. I think between then I like updated my graphics driver, messed around with my monitor to put it back up to high frame rate. So yeah, let's go ahead and check that in to our GitHub. And I can go ahead and push the latest version to Heroku so people can play it if they want. Let me switch over and get that updated. Let me just check something real quick with my GitHub repository. All right. I think I pushed it. Let me log into GitHub and make sure my change is there. Let's see. Okay, yep, that's there. So then let me go over to Heroku, and I can kick off a deployment. All right, now that that's done, let's go ahead and go back to the strategy game. I just feel like I had to get that out of the way. It was bothering me. Okay. Quick water break. Alrighty. So now we're back to the strategy game. Let me resize the window a bit, since this game is a different size. Let me see here. Alright, we'll probably use some of that space at some point, but yeah, so where we left off, I made it so you can move, and there's some animations showing the attacks going off. And some, when you kill a piece, it explodes. So it's pretty cool. Unfortunately, it's pretty hard to not draw at this point, just because of the way things work. So I went ahead and launched some ideas I had that might, completely change how the game works. So, like, if pieces only attacked every third turn, that might be interesting. That would, give you a chance to position things around before the attacks go off. Another idea I had was, like shogi, you can replay the pieces that you've captured on the board. That way you kind of don't really run out of pieces. So that might be interesting. I had another idea. What was it? I think I forgot. Yeah, I don't remember what else I was gonna do there, but yeah, so we've done a decent amount here. Let's go ahead and put in the victory condition, since it's kind of dumb to end up at this screen where you can't really do anything anymore. Let's go ahead and do that. So let's go ahead and have the engine effectively tell us that the game is over. Then the UI will be responsible for showing that the game's over and giving us a way to restart. Pretty much the same thing we did with the DodgeGame. So probably somewhere after execute, in the round. So we executed the moves, we did the attack phase. We should determine if the game is over, and we can store that in the log as well. That way, when the front end goes to retrieve the log, we know if it's game over or not. So let's just go ahead and put maybe we'll just have like a game over field, and it will be maybe it'll be a number. No, let's make it an object. We'll go ahead and make it an object. So it'll be actually, what we could do is we could have like a rather than game over, we could just have it be like state. And the different states are going to be like plain, and player 1 win, player 2 win, and draw, or tie, draw, I don't know, draw, maybe something like that. And do round. So it'll start off at plain, and then this dot determine game over. We'll go ahead and put that at the bottom. Alright, so, the way we know if the game is over is if the king has been captured or not on either side. Simplest way, we can probably just loop through and see if there's a king for each piece or not, and if it exists. If it still exists, then game's not over. Because in the attack phase, we would have removed the piece if it was killed. So yeah, let's just go ahead and do that. Maybe we'll have some variables like e1 king, e1, my king found 1 equals false, king found 2 equals false, and then we'll just go ahead and go through the board and see if we can find the pieces. Yeah, so we'll just do the for loop over the board size, get piece. Yeah, we'll do all this stuff basically. So go through the board, get the piece. If it's a piece, and the piece type is piece type dot king. So if it's a piece and it's a king, if the piece dot owner equals or 1, I'll have to look that up. Then king found 1 equals true. Alright. Then we can have the logic to determine if it's over. And I think we saved the player IDs somewhere, maybe. Did we? We've got this players array. Yeah, so we'll use that. So this dot players 0. What is the player? We call it add player. Oh, that's just the object. What was our player interface? Currently it just has one round update. We might want to go ahead and add player ID. Let's see. Okay, the player ID is pretty... Right now it's just where you are in the array. We could just stick with that, I guess. Or we could add that as part of our interface, right? Player ID. Maybe let's try that. We'll see how that works out. So we'll add player ID as part of our interface. And then down here we can just say player ID. Alright, it's a little weird because the return value of this function is the player ID, but we'll worry about that if it becomes a problem later. I don't think that'll be a problem. Alright. So then we just need the logic piece. So if king 1, if king 1 and king 2 are found, then we're good, and we don't have to do anything. let's see. Yeah, TypeScript couldn't figure this out. I thought I'd be able to figure it out. We don't really have to put the state here, but might as well, just for you know, completion's sake. So then this is pretty straightforward logic. I hit some hotkey that removed something down here in Visual Studio, but I don't know what it was. It probably wasn't anything important, right? It's probably fine. I think, yeah, that I don't even have that on the bottom on screen for you guys, so who knows what was down there. Missing a bracket. Okay. Alrighty. So that should get our state all set up correctly. Next up, let's see. So now we've determined the game state and put it into the log. That gets pushed into the log. Now on the front end, we need to actually like read the game state. So that'll be in like the next round update, or what did I call it? What did I call that, guys? On round update. Yeah, there we go. So what we'll do, get the last round log. I don't think we want to actually we want to wait until we show all the movement and attacks, and then after that, after all that's done, and then we actually go to update the board state. That's when we want to update our things. Sorry, I had to blow my nose there. Allergies are acting up today. Alright, so now, let's go ahead. We should probably really break this out into a function. Like maybe like after all animations or something like that. And, that's when we're going to actually update the board state. So we'll update the board state, and then we should do update game over state. Or like check if game over. Probably should be another function, but for now we'll just so then if log.state is log game state, I need a good way to share that. We can put it in the items thing. Alright, so that'll let us share the code. Alright, so if it's a draw. Actually, let's do if it's not playing. Then let's here we'll break out another function called like game on game over. And we'll go ahead and call that. And then maybe we'll just go ahead and put some text on screen. That seems simple enough. So then we'll have conditions for each different stage. And then we'll show text for each one, and really we should make sure we disable the buttons too. But yeah, we'll do that too. Alright, let's see. We'll probably want like a game over field, and maybe a game over text field. Let's go ahead and figure out where the text should be, what it should look like, that kind of stuff. We'll just go ahead and copy one of our existing texts. So that's the big strategy game text. Oh, sorry, I had to sneeze. Let's see if we get that on screen. We'll move it down a little bit. Let's move it. I've got it with the origin. Let's do origin 0, 0. Now we'll move it up a little bit. Alright. We'll just do like game over colon. Or actually, yeah, so we'll just go ahead and create this here. Then we can just do like set text to whatever we want. So in this case, you're player 1. So we'll just do you win or you lose. Alright. So that'll do that. And then yeah, so this input stage should really go to the game over. That way, that'll prevent you from clicking on any of our other buttons. Let's see. Was there anything else I wanted to set first? Well, we can go ahead and see what we've got now. So let's go ahead and so I've clearly got some kind of bug because the king's still there. So most likely my my logic that determined if the game was over or not is what's wrong. Or it could be a main scene. Let's check main scene first. So if the state is not playing, then we do game over. So that seems correct. So we should have started with the stage should start at playing. Determine game over. So maybe here's what's wrong. I had the wrong index there. Okay, so now it's not game over. And then if I move up closer to him, we kill each other, then we've got a draw. And we can't click anything. Let's start over. And I'll see if I can do it with my piece. So my piece is still on the board, but clicking it does nothing because that input state. I need to disable the buttons. I'll add like a disabled state to the button and make it grayish. Let's do that. So for my text button, let's add a field called enabled. And what we'll do is add some functions, or just one function really, called setEnabled. Then we'll toggle the enabled state. And then we'll really want to set the color based on what's going on. So let's add a disabled state, and then we need gray. Let me just look up what gray would be good. Maybe kind of a lightish gray, so you can see it. Yeah, let's go with this color. So what I think I want to do is maybe have a like a update the button color function or something like that. Update button color. So then like if it's not enabled, then we want to go with our disabled color. And otherwise, so what we'll now want to do is we'll want to call this function from in here. So what I want to do is have the button know kind of the last thing that's going on. So the way we're going to do that is I mean, I guess I don't really have to worry about this. Let's see. So what I've kind of gotten myself into here is I started trying to account for like if it switches from enabled to disabled, or really from disabled to enabled while your mouse is over it. But I don't. Now that I'm thinking about it more, I probably don't really care about that. Let's, as always, simple is best. So what we're gonna just say is, we're only gonna, well here for sure we need to make sure that, if it's not enabled, we don't really want to do any of this stuff. In fact, that might be true for all of these. That might actually be all we need to do. Let's go ahead and do. We still want to call it there. Okay. We can decide to make it more complicated later if we want, but for now, we don't need to do that. Keep it simple, stupid, right? Keep it simple. Alright, so then, let's go ahead and disable the buttons by changing the, when we're in game over, set enabled to false. Same thing with the undo button. Let's make sure that works. Oh, button doesn't work at all now. Yeah. I thought I set enable to true when I was, I did set it to true. At the start. Right, so we actually need it to be this, not, we don't want the button to work if it's disabled, right? There we go. Let's go ahead and, get a game over state, so that gray is, let's gray out the text too, and maybe pick a slightly darker gray. Let's go with this color. And text color is going to default to white. And we'll do the same gray for the disabled color. Alright. Let's see. Here is where the color is. Oh, so it's gonna want the string version of that, right? So let's do that. Then on our set enabled, go ahead and here this text. Actually, hold on, because this is a container, right? Yeah. So no, text is, yeah, text game object is what I want. So this text game object set style. No. Hold on. Let's go ahead and get our autocomplete working for us by filling that in. And then it's going to be like set style, I think. And it wants to take the style object, which is just this thing we had before. I probably can get away with just setting the color. And one of these needs to be disabled. Alright, I think that'll work. I should start the pieces closer together if I'm going to keep testing this. Alright, so now it's disabled and it looks grayed out. Cool. Let's go ahead and make it so you can start over. Maybe we'll just do the same thing we did on the other game. Oh, the thing that disappeared was my Windows Start menu actually is what disappeared. Because there we go. I made Visual Studio full screen. There we go. Alright, let's see. So now we want to go ahead and make some text that's like, you know, press spacebar to start over or whatever. But let's go ahead and just copy some of that logic from my other game. So I'm gonna open another window here. You can't see it, but I'm gonna open the DodgeGame and copy out the stuff about the keyboard controls. Alright, so over at main scene, actually I could just make another button pop up instead. Since we're not using the keyboard, maybe actually now that I think about it, it probably doesn't make sense to use the keyboard since we're doing all buttons here. Let's just add a start new game button. In fact, I could have that there and you could just start over any time. That might be handy for testing. So let's add another text button where I have my other text buttons. We'll just plus equals for the height of the previous button. And some buffer. Maybe we'll put this button down a little further, just so you don't accidentally click it, right? Let's go ahead and add these fields. And we'll add our function. Alright. Let's see. Next up, yeah, so when you click new game, we're basically going to want to reset tons of stuff. Like this input state is going to have to change. But we're going to want to do a lot more than that. The game over stuff will have to change. Go back to game over is false. The game over text, dot text, we'll want to set that back to They're like, set. What did I do before? Oh, I just said .text. Let's go ahead and what else are we gonna have to initialize here? So I probably will want to make it so you can't click the new game button while the animations are. Really, you shouldn't be able to click any of the buttons while the animations are going. But we'll worry about that in a bit. Probably want to just go ahead and create a new board. Or we could add a function to board. Let's see what happens when you create the board. That creates all the lines and initializes the spaces to null, interactive. Okay, we don't really need to create a new board, but we do need like a clear all the spaces. We probably want to create like a new engine and start the game again. Is my guess. Probably gonna want to do this stuff. And what we can do is like kind of like the other game. I want to have I probably want to call this function at the very beginning just to make sure everything's going correctly. Let's see what we can do. That's all fine, I think. We are going to want to re-enable our buttons if they've been disabled. Let's go ahead. Go ahead and call a new game clicked here. And then I can remove this stuff from our constructor. And I should really rename it. Isn't there a fancy way? Yeah. Okay, F2 does what I want actually. We'll call it like begin new game. Alright. So that should be good. I don't know if there's anything else I need to mess with. This might be enough. Alright, so our game started, it looks like. Make sure we can move. If I click the new game button, it should all start over. Alright. Cool, so we've got the new game started again. Whenever we want. But you can click it during the animations, which is pretty weird. And maybe will lead to some weird behavior. So let's disable the new game button while on the round update. So this means our engine called us back, and we're about to schedule a bunch of stuff. So let's go ahead and disable the button here. So this, we'll do it here. New game button. Did I just call it new game? Yeah, let's call it new game button. Dot set enabled to false. And then the move tween's finished. We show attacks. Assuming there is a piece. Yeah, we should just put this after all animations. Yeah, this is where it should go. Here is where we want to set it back to true. Alright, so that should disable the button while... And I should really disable confirm and undo as well. Let's go ahead and do that too. Alright. Now all the buttons should be disabled while we're... So you notice that it's still red there. Probably because, probably some kind of race condition between my logic. That is kind of weird, isn't it? But my guess is if I go over to the text button, what's happening probably is we're calling the onClick, which that is what calls a bunch of other code, which is eventually going to call, you know, the set enabled to false. But then we finished onClick and we would have called set stroke style. But now that I've put it in the opposite way, you can see that it works fine. Alright, so now we can restart our game, so that's cool. Let's go ahead and mark that off of our to-do list. We've got the victory condition down. We haven't really tested. We haven't tested if either player can actually win. I guess I could at least test that for myself if I move in front of his pawn. Okay, so the you lose condition works, so that's good. Presumably the other one works too. So I could make the buttons a little bit nicer. So like confirm should really only be enabled if we're in this state, right? If we're in this state or this state or this state, yeah, if we're in this state or this state, then confirm shouldn't really do anything, right? So actually, okay, new game still works there. Let's go ahead and do that just to make the buttons more clear of when you should be able to use them. So the confirm button and the undo button should both actually start at false, probably. Then when you click somewhere, where did I have that? It's like click square or something. Because it's when the board calls you back, right? Click square. So if we moved... Alright, so if we change to the piece selected, then we can go ahead and enable the undo button now. And then if we switch to waiting to confirm, then we can go ahead and enable the confirm button. And if you clicked undo, then what we can do is go ahead and disable both buttons. And I think that might be roughly what we want. So they're both grayed out to start. I click a piece, undo is now highlighted. I click undo, it goes away. And now if I'm here, undo takes us back. And confirm, yep, all right. So that cleaned up the buttons a bit. Now it's a little more user-friendly. So that's cool. So now let's let's actually make it like more of a game, maybe. That you can actually, you know, have fun and win. So I was thinking, for initiative, I think it would be interesting if some pieces attacked before others. Because right now, for example, there's no way. Well, right now it's really stupid, right? Because everyone just kills each other all at the same time, which that's kind of dumb. So what we need to do is, like, it might be interesting if the pawn attacked before the king. That way, you know, you actually have to worry about your pawn a little bit. My thought is that the king should always attack all around it, but it'll attack last. That way, it's a lot harder for the king to survive when other pieces are attacking it, and you kind of have to rely on those other pieces to survive. So, what that means is we'll need like multiple attack phases. So each piece is going to have, I'm going to call it an initiative. I threw in the speed variable earlier, but I don't think I want to use that. Let's have initiative be a number. And the initiative will be based on which piece you are. So let's go ahead. What we might want to do is make some. We'll make a file called like piece definitions or something like that. We'll go ahead and make that in this folder maybe. Call it like piece def. And what we're gonna want to do is put a lot of our logic, like the available moves and the type, and actually, so yeah, let's so piece def we're gonna export. We're gonna do an array, and the array is going to be ideally it's just keyed off of I guess it doesn't need to be an array. Let's see. I kind of want it to be like, what I want to be able to do is say like piece def, like piece type dot king, and then get at its properties that way. I'm not exactly sure how to do that in JavaScript. How do I do that? Because I want to like statically define an array. Well, it's not really an array, I guess. I mean, it is an array, but it's not a sequential array, which is pretty weird. It's more like a map, I guess. Yeah, let's look that up actually. Oh, I guess what I could do is just say like I think this will work. Probably a little bit messy, but it should be fine. So then we'll do like the available moves. So I probably need the type here. Make an interface maybe. All right. I think that's what I want. All right, let's try to put some more fields in here, like attacks. And initiative. Go ahead and just copy this stuff over. And for the king, he'll have a really low initiative. Maybe our initiatives will be like from 1 to 5 or something to start, with 1 being the slowest and 5 being the fastest. Alright, so I've got all that in there, and then from logic piece now, what I should be able to do is import import the pstaff, and then I should be able to say like should be able to say like this dot available moves equals pstaff type dot available moves. Should be able to do that. And this dot attacks. And this dot initiative. Let's go ahead and copy the pawn stuff over to our pstaff. Alright. The attacks in there. Alright, so now the pawn's there too. So I don't need this anymore. It looks like maybe I've got an error. Let's see. This might have to do with how things are imported. I'm not exactly sure. For now, we're just gonna copy the enum over, which I think will resolve that. Oh no, it doesn't like that still. I'm kind of surprised that that doesn't work. Alright, what we can do... we'll have to keep the arrays in sync. We're just gonna do this for now, just to keep things simple. Because I don't really want to worry about... Oh, it won't let me do that either. Oh, hold on. Maybe I made the thing. I thought I could just do it this way. But I'm getting this Webpack error. Let's see. Yeah, I mean, Webpack and this JavaScript packaging stuff is not my specialty. So I'll have to think about this a bit. I thought I would be able to just have it be imported this way, but I guess it doesn't like this. I mean, worst case scenario, I think for now I can just put this all in logic piece and worry about moving it later. It's kind of lame though. Okay, that's not right. Yeah, I thought I would be able to do this, but I guess not. For now, let's just go ahead and it's kind of bad, but we're just gonna put it all in here. So maybe it won't even like this because we'll see. It might not even like that. Yeah, it doesn't like that either. Yeah, I need to look up how to statically define stuff, I guess. But that's fine. We're not done yet. There's still more ways to do it. So we're gonna move it to like a I kind of don't want to put it all in logic piece. Let's go ahead and put it in logic board, I guess. So we can just put it in the constructor here. This is a bit of a mess. I'm sorry. I'm sorry this is such a mess. I'm gonna be pretty annoyed if the only issue is that it didn't know how to make the object. Well, we're about to find out, I guess. Alright, so when we create the logic piece, let's also pass in the piece definition. I guess that could really be... I could have the type in there too. Yeah, so now that I've got it up here... Yeah, let's do... No, don't do that. Just type that... King... and pawn. Yeah, we'll go ahead and add another field. Called type. Alright, so that'll define our stuff. We don't need type anymore. Yeah, we don't even need this because I'm passing in the exact one that you are. Alright, so that should simplify that a little bit. Then we just need to pass in, when we add the piece, instead of type, now we're going to pass in that. Alright, that should be mostly what we want. Looks like I've got some errors. Oh, it's probably... we're gonna go ahead and delete this file for now. We're still getting an error. Yeah, I think the reason this didn't work was, might just be as simple as that. Yeah, it doesn't like that. That's fine. So now we just have some TypeScript errors. Yeah, I can probably move it back into the other file now too. I'm trying to decide how, okay. Yeah, well, this is how we should have done it. Yeah, I'm dumb. I'm pretty dumb, aren't I? This is what we should have done the whole time. It's all good. Alright. Well, that's fine. Alright, now I can delete all this. Alright, then we kind of want to do the same thing for pawn now. Alright. Make sure that works. Alright, so this stuff's working. And now that I've butchered it, let's let's go ahead and put it back. So we'll make our pstef file. Now that I've figured out what I was doing that was stupid. So what we're gonna do is copy all this. Save our pieces. Equals this. We still might have a problem importing the piece type though. For now, let's do what we were thinking about with just copying it. Where did I define that? Oh, it's in the, this enums. Let's try importing it and see what happens. Alright, so we're gonna try importing it. Not sure what the error is there. Let's delete pawn for now. What's the error now? Piece type is not assignable to type never. Oh, it just wants the definition. So we'll just grab that. Okey-doke. I think that builds now. Let's go ahead and grab our other piece, the pawn. And then let's export default pieces. Okay, after all that, I think we're gonna be good. I'm confident enough. I'm gonna delete these piece definitions from here and from here. And we're gonna do import pstef from pstef. And I don't think I need this anymore. And we're gonna say pstef type. And it's just gonna work. It's just gonna work. Alright, what do you know, it works. How about that? when you write code that makes sense, it actually works. Alright, so now all of our piece definitions will live in this file, and it'll be easier to add pieces later by modifying this file. So yeah, we were adding the initiative here before we got mega sidetracked. Okay, so let's see. So this is stuff that all comes from the piece definition. We can probably, there's probably even like I want to say that there's probably a fancy JavaScript way to assign all the fields from this object into this. We're not going to worry about that now. For now, we'll just leave it as explicit. So let's start trying to get the initiative stuff going. So that would be in our engine. So what we'll probably want to do is split out the log. If it's a matrix of attacks, like the idea is you would have like attacks at, initiative 0 would have, some attacks in it. Yeah, let's think about it like that. And actually, let's go ahead and make our initiative 0 based. Just for ease of use. All right. So let's see. What we'll do is what I was just talking about. So if I make attacks like a matrix, let's see. I don't know if I need to, I don't think I need to bother with that. So what we want to do is we're going to want to go through the pieces. Yeah, so we kind of want to do an attack phase for every initiative is how we're going to want to do it. Yeah, that's what we're going to want to do. So we're going to start at the highest initiative. Let's go ahead. Where do I want to define that? Maybe here. So we're going to want to start at initiative max and go down from there. Make sure we do minus minus, right? And the idea, so that now if I'm zero based, we'll worry about the initiative max later. So what we're gonna do is for each initiative, we're gonna say like log tax of the initiative is a new array. Let me just check some stuff, make sure I'm doing this right. So we're passing the log in, and the log is a double array of attacks. Okay, so we pass it in the whole log, and alright, so I think this makes sense. So then for each, we're basically going to do all this stuff, but at that initiative. So, yeah, I think for now, I could probably make it another function, but we're going to just pass in, let's see, we're going to go ahead and use more descriptive variable names. Alright, so for each initiative, you make an array for the log. So if we find a piece and that piece dot initiative is our target initiative, then we're going to execute the attacks for that piece. And then we don't need to worry about that for the damaged pieces section. And then what we can do is we can pass in like log dot. We can do it like that, and then the log will be the attack log. It should be an array of those, right? Yeah. And then okie doke. I think it's as simple as that. Now, that should all work out. I think I got it right. We'll have to test some to make sure that it's not totally broken. But yeah, I think this should be good. I think this will be good. Okay, so now we've done the attack phase, but we've done all the different initiative steps. So the rest should be the same up here, but now we need to make sure that all gets animated correctly, right? So thanks to the power of TypeScript, I now know that some stuff is wrong in main scene. Let's go ahead and make sure we're in the right spot. So, show attacks. Let's update this first. So since we're doing it by initiative, let's go ahead and split this out. Maybe pass in an initiative for the attacks. Yeah, so let's say let's have like a current initiative for what we're animating. Current animated initiative. And let's call it that. So then when we start off, we want to set it to the max initiative to start. And yeah, so then show attacks. What we'll do is this guy will say let's see, let me just write it out as I'm thinking it. So we'll say, like, if the we need the round log for sure at this point, so get the log, and you know, it has to exist, of course, but it should be guaranteed to exist. But go ahead and make TypeScript happy. So then we're going to want to look at the attack log for init. It's going to be log.attacks. This current animated initiative. And basically if that length is greater than 0, then we want to actually do stuff. And if it's not, we kind of want to loop around. Let's see. Yeah, I'm just trying to decide exactly how I want the call pattern to go, since there's a couple ways to do it. So I kind of want to, you know, I know I don't have pieces at every initiative, so I expect this to be empty. So what I could do, let's just do something like, while this length 0, then we'll go ahead and decrement the current initiative and go ahead and grab the next one. Yeah, but we also want to make sure, and this is greater than 0, because as soon as we hit -1, you know, this doesn't work. So then what we can do is we can say, if current animated initiative is -1, then we're done. Otherwise, we want to schedule some stuff for our current thing, which we know has some stuff in it because of this this length here. So let me shrink the game down a little bit. It looks like it might be blocking the way. So yeah, I think this logic will work for us. Yeah, so if we're done, in this case, it might be something like, we reached initiative 0 and there were no pieces at initiative 0. Right now, that's not really possible. I mean, if I deleted the kings, then that is possible, I guess. So in this case, I think we're just going to want to go ahead and call into One attack between complete. Otherwise, then we're gonna schedule the attacks for pieces at that initiative. So really it should be, I mean, since we're doing every piece. Oh, so I've messed it up a little bit. So we don't actually need to look at the log, I guess. We just really need to know if there are pieces that exist. And they're not dead either. Oh. Yeah, I've made it, it's gonna be a little more tricky. So the problem is, I had initially set it up so that we show every single piece's attack all the time. Whereas what I'm kind of doing now with looking at the log is I would only be showing, you know, when they actually do the attack. So that's not quite right, you know. But I also have to account, if I do want to show every piece's attack, then I need to account for when pieces have been removed. So what we should probably do is and that information is effectively in the log because it tells us which pieces got attacked. Yeah. Okay, so what we could do is we could just go through each initiative. Oh yeah, what we're gonna want to do is something like show all attacks at an initiative, and then we're going to want to remove pieces that died, and then we're going to want to continue with the next initiative. I think that's what we're going to want to do. It's going to be a little more complicated. Let me take a short break, and I will be right back. And I'm back. Alrighty. So yeah, let's go ahead and go with this plan. So I'm actually not gonna need to look through the log. But I will need to look through the board to see if there are any pieces. And I'll probably also need to use the log. Yeah, I think how I want to do this is have a, I think I want this function to like return a boolean. And then that's going to be whether it showed attacks or not. And it's also going to have an initiative for whether it scheduled any things. Yeah, here's what we're gonna do. Oops. Actually, I don't know. So, if it returns true, then we're done. Because then we'll know stuff has been scheduled. Alright, so then, what we're gonna do probably end up putting that back in a second, but so let's so the delayed call here, yeah, I'll have to think about that some more in a second, but I think that'll probably be okay. Yeah, because what this will be is it'll be at the current initiative. Something like that. And then something like that. And that'll actually be everything we need there to have this function work. But we're not going to want to schedule it every time because we're going to want to check. We're going to want to check this. So yeah, if there are attacks at this initiative, then we're actually going to do stuff. All right. And then we're going to return true. Because that means we scheduled stuff to do. So this still isn't quite right. It's not that there's. It's not whether the log has stuff in it. It's whether there's pieces on the board at this initiative. That's what we want to know. And I don't have a good way to do that at the moment, but let's see. I think what we'll do . So we could use the graphical representation of the board. There's a few different ways we could do this to make it easier for ourselves. One way would be potentially putting something in the log just to make it easier to look at this, look at what we want here. Yeah, maybe something like that would be the easiest way to do it. So for each piece on the board, okay, yeah, what we can do, we are actually already looking through all the pieces on the board. No, I don't want to do that. That's where that should be. There's kind of no reason to schedule it before this other thing. So, yeah, let's go ahead. Hold on. Something's not right here. Okay, there we go. So, yeah, let's have pieces that this and it as false. And then as we iterate through each piece, we want to skip it if it's not the right initiative. If piece not initiative is not or what we're looking for, we're going to skip over it. I know why that's broken, but we'll worry about that in a second. Alright. The reason this is broken is because we're looking at the board representation of the piece. So what we need to do probably is add that into the board representation of the piece just to make it nice and easy for us to grab that initiative out. So we're passing in piece type already. Actually, since we're copying a lot of the logic here, we'll probably want to go ahead and use the piece definition stuff that we had from earlier. Yeah, piece def. Probably just pass that in. When we create the piece in a very similar manner to how we did it here. Yeah, so we'll go ahead and import this there, and then when we add the piece, we'll go ahead and pass in the actual piece definition there. Maybe not here, but down here. That should do what we want. Then in add piece, yeah, here it's actually going to be a piece definition. You can do piece definition dot type, available moves. You know, basically, I'm going to copy the stuff we did in the board or the logic version of the piece. Highlighted. It's because I don't have attacks listed. We might want to show that at some point, so we'll go ahead and copy that over as well. Okay, and then pass in this dot type to get our letter. And I was thinking maybe we can display the initiative as well. Here. Maybe we could just do like letter plus equals that way it'll be like the letter plus the initiative, and we'll go ahead and just add 1 to it to make it look better. That way we don't have 0 on the board. We'll see if this actually works. Let's see. Now we have the initiative in here, so it shouldn't be any problem calling initiative here. Alright, looks like built at least and deployed. But I think I still have more work to do. So, right, we scheduled, yeah, what we're going to want to do is kind of copy this loop here. And, when the animation tweet's complete, we're going to want to go ahead and do this again. Oh, let's see. Do I have something weird? Yeah, so what we should do, I've got something a bit weird going on because the scheduled code is actually caring about the initiative. So that's gonna be a little weird because it'll be off by 1. If we just want to be super hacky about it, we could just add 1 here. That's pretty bad. I probably shouldn't do that, but I am, because I'm a bad person. So then, if current initiative is still greater than or equal to 0, we're going to want to try to show the attacks again. And so here we're going to say if if we manage to get to yeah. Oh, what yeah, this is a bit of a mess. All right, so if we're not at -1 yet, we'll do this. Yeah, here we go. Scheduled attacks is false. Here we'll say scheduled attacks equals that. Not scheduled attacks. All right. Then if we have not scheduled any attacks, then we're finally done. And we can go set up the next round. Okay, so that should all be good. One last thing we're going to want to do is we need to remove the pieces. We need to remove the pieces that die because we don't want them to still be there after they die at that initiative. So what we'll do is after the attack is complete, and we're not waiting on tweets, before we go to schedule the next attack, what we're going to want to do is remove pieces that died during last animation, and then schedule next attacks. If nothing to schedule, round animation is complete. So this should be the last piece we need here. Basically, we just want to remove them from the board, the graphical object version of the board. Okay, so yeah, I'm not really liking how I've subtracted. It's kind of nasty. All right, well, move pieces that died at initiative. So see, I have to pass in the +1, right? Which is kind of dumb because why is it +1, right? But whatever. This is a bit of a mess. Okay, so what we want to do is we want to look at the logs and basically the same exact code we did for the explosions. Oh, I've actually... So this is the explosion sprite that's getting killed. What we might want to do is actually also destroy the... Yeah, I might not even need to do this here. Yeah, I'm kind of putting a bunch of logic in my animation code, but it's okay. Alright, so we figured out this is like the position where we want to play the explosion because it's got the target. So that's where we're playing the explosion, but we also want to delete the piece after the animation is complete. That way it's not there anymore. So it's a little tricky because it's going to be the piece before it moved, right? Because the tweens, we didn't actually update the row and column of the piece. Right, because the graphical representation is kind of like one round behind until we update the board from the game state that was passed in. So this is a little weird, isn't it? This is where it would help to have each piece have its own ID. That way it's be much easier to find and delete the correct piece. So I might try to do something like that. Maybe we'll go ahead and add a piece ID in. That way, it'll be a lot easier to do what we want here. So, what we'll do is in this add piece function, wherever it is. Oh, it's in board. All right, so this an add piece function. Let's go ahead and make a member variable that's like next piece ID. We'll just start it at 1 for funsies. And we'll pass this in when we create the piece. Okay, so now all the pieces have IDs. We should probably increment the ID. Okay, so now they all have IDs. And one thing I want to do is when we update the board, the graphical representation, we want to make sure we copy the IDs over. So when we update the board state, yeah, update board state. Let's go into that. So we go through, we destroy each piece, and then we add the piece. Let's go ahead and add the ID as well. Let's do it there. Okay. So now we should have an ID for all the pieces. And then in the log, let's go ahead and add in the log which piece was destroyed. When it takes damage, attack. Let's add like attacked piece ID is target piece.id. And attacker piece ID is piece.id. Alright, so let's add those fields to our do I have should be in the attack log. Okay. So now the log has the ID of the piece that was attacked as well. That should all make things much more handy to actually delete the piece. Now that we've done that, we just need to find, I'm going to put a comment here just for this is the first round, right, because we didn't have a log. Okay, so, I was about to delete the piece that died, and this is the attack. So the attack should have an attacked piece ID. And what we should be able to do is just say like this.board.remove piece by ID. Should just be able to say that. And then in board, I don't think we actually even have a remove piece at all from this board. So remove piece by ID. We'll need to loop through board and find the piece. So we found the piece, and the piece ID matches. Then we want to destroy it, and we want to set the piece.row, piece.column to null. So that'll get rid of it. We can go ahead and break at that point, or return even, because we're done. Alright, so that should get rid of the piece. Assuming I did everything correctly. So we should probably add in some more pieces to make this a little bit easier to verify. I mean, first let's make sure. So the animations didn't play there, and we're also stuck. Looks like we hit an error with my stupid +1 line. Line 241 is our problem. And nope. That's line number is not quite right. It's off by 1. Alright, so basically it was saying that this didn't exist. I think what we're going to want to do is add another variable about the initiative just to make it more clear what's going on. I mean, I could also add some output to Bugspew as well. Oh, this is what's wrong. There we go. Well, yeah, I was doing it if the initiative was not. Yeah, why did I have that? Oh, now something else is broken. Really? Did changing that one thing broke something else? Are you serious? Or do I have another file that I haven't saved? I haven't saved, what? What's this unsafe file? Logic piece. Okay. It's weird that I can't clicking. It's because it didn't finish moving, I guess. Yeah, there's some weird stuff going on. In this case, we probably want to put in some debug output just to, you know, make sure things are correct, what we expect. So when you start having all these callbacks, right, it gets pretty complicated. So we could just dump in a bunch of debug spew wherever we think would be useful. So this will be, we can go ahead and get this, grab this too. Alright, so we'll log out some stuff. So this will be if we scheduled some stuff. Go ahead and have an output there because that's what crashed last time. Go ahead and have some output here. And we'll talk about scheduled attacks as well. And then just to make sure we get here, let's go ahead and have this final log. Alright, that should be enough logs to get some action going. So pieces of this init 2. So there were 2 at init 1. Yeah, so is play attack animations at 1. But I'm doing the weird +1 thing. Let's see. So we didn't see this scheduled attacks log output one attack screen complete. So that didn't happen. We didn't see either one attack screen complete log. So that means that didn't get called, which means we probably didn't schedule it right. Let's see. But we did see pieces of this init was greater than. Huh. Interesting. So I would have thought. Let's go ahead and put a debugger line here. I would have thought we would have been in here. Alright, so we did hit this debugger line. But the problem is piece type is undefined because I copied the code and changed it. Yep. I thought it might be something like that. I thought it might be something like that. So the problem is that my definitions aren't quite matching up here because I used type here. Why did, oh, and JavaScript, yeah. Because type is part of a container, but we don't actually want to use that. And so we could have fixed that by having piece type be the type here, and that would have caught it for us. But that's okay. What we should do, yeah, okay. I think that'll fix that problem. So now piece type is correct. All right, so we got past that debugger line. The pawns showed. The kings showed, and then we're back to the next round, it looks like. Yeah, let me delete the debugger line. I already did. I didn't save it, though. Alright. Let's see what happens now. So it's a little weird that the pawns played twice. Not exactly sure why that's happening, but we can check that in a second. Okay, so oh, I should probably, as soon as the king dies, maybe game should stop. And there should be no more attacks after a king dies. Let's make a note of that. No more attacks after a king dies. Okay. Let's find out why the pawn animation plays twice. That is pretty strange. We can probably look at my debug spew to get a better idea. Let's look at the console. Quite a lot of console debug spew here. I'm not gonna show it all to you, but we do it at current initiative 1, then we do current initiative 0, and then current initiative -1. Interestingly, yeah, so the problem, I'll copy the relevant debug spew so you can see it. So the problem we're seeing is, this is my debug spew. So let me, so the show attacks, pieces that this and it were 2 when the current initiative was 1. So that's this debug line. So that makes sense, right? Right? Yeah, that makes sense because there's 2 pawns at initiative 1. So then we play the animation. The tween completed. So still, this +1 is what's bothering me. So this got called with a current initiative of -1. Hope that makes sense, right? That makes sense. Okay, so I think maybe the problem... So when the attack chain's completed... Current initiative was 1 the first time. And the problem is... We probably want to do it like this. No, that shouldn't be right, right? Yeah, I guess the first time... So show attacks is getting called 3 times. Hold on, let me copy that. This is a more complete of my debug spew. Oops. Okay, so show attacks got called 3 times, so that's the problem. It got called twice at the same value, which is clearly what's wrong. So like we're show attacks to a minus. So there's 2 pieces in initial 1. We did the... I don't understand how it's still 1. How it's still 1 here. Because I would expect... hold on a second. Alrighty, sorry about that. Had to take that phone call real quick. Nothing, no problems though, just I needed to talk to that person. Alright, so let me figure out where in the world we were. We were trying to debug a problem. So the reason I'm confused is because we call show attacks, add a value, and then after that we subtract. Okay, I get it now. Yeah, I understand what's wrong. So it's only if show attacks returns false that that we're doing this decrement. That's right. And that actually makes things make way more sense. Because, okay, now I don't need that +1. Yeah, this will all make way more sense now, I think. And, what we want to do is we want to subtract 1 now. And then, I think we're good now. Oh, but, to have it match up with the other, if not scheduled attacks. I could probably clean this up a bit, but I think this is what we want. I think we're good now. He blocked me. Come on, I'm trying to test here. Oh, so we still showed my king. My king's animation, which is wrong. Though it looks like he did remove my piece, we still played the animation for him. Let's figure out why that is. Probably because we went through the board. I feel like for each piece should not have found him though. Because I thought I removed him with this remove piece. Unless I got the wrong spot. No, I mean that... Let's go ahead and put a log here. Okay, so that'll be a log when we remove him. And then, let's go ahead and just log some stuff. Yeah, we'll log that. And also what I'm gonna do, getting tired of making 2 moves, so I'm gonna just set up my initial piece to be closer to where I want to be. 1 row higher. Nope, that was the enemy piece. Alright. So for each piece, certainly called, it was called multiple times, right? Well, let's go ahead and also put a log, where we called, in main C, where we called remove piece. Alright. So I've got some kind of error. Where's that at? 257. No, right here. I didn't have my plus. There we go. Alright. So let me look at all my debugs view now. My beautiful debugs view. I don't see. So it removed the piece much later than I thought it would. I wonder why that is. Because it should be at the pawn. Yeah, it removed it at the wrong initiative. In fact, it removed it after all the animations was called. Which that's actually quite surprising. I guess it removed it in update board state. Hold on, that doesn't make any sense. Aha, this is the problem. I believe that will fix it up. No, still not right. Actually, I wasn't even really paying attention. I was looking at the debugs view. Yeah, so why is that happening so much later? Oh, is the animation just take that much longer to complete? It's possible the animation takes a really long time to actually complete. Yeah, that's what's wrong. So I kind of want to remove him. Yeah, I want to remove him like here. Not use itself anymore. Okay, maybe that'll work. Yeah, basing it on the animation was a bad idea. Okay, so that looked pretty much right, yeah? Sweet. I think that's what we want then. Alright, let's go ahead and remove all this debugs view. We don't need that. Alright, and I think we had one line in here somewhere. We don't need that. Alright. Let me just do a big search for console.log. What's this? Oh, that's main scene. That's okay, cool. Yeah, so we now have that all playing correctly. So that's good. It would be nice to do no more attacks after a king dies. Let's go ahead and make that change in the engine. So, execute attacks, attack phase. So basically, at the end of this loop, we want to check for a game over condition. Because we would like to stop executing attacks if we're in game over. So, we could go ahead and call it determine game over, maybe. And then just check if our state changed. Maybe that's what we'll do. Go ahead and pass the login. And then if log.state equals log game state dot, if it's not playing anymore, then we'll stop, basically. Go ahead and break out of this this outer for loop. So that should fix it up for us. Ooh, that's not good. Interesting. So probably instead let's make sure we actually have our instead of breaking out, what we're gonna do is just make sure we have our all of our arrays defined, because I think that's probably what that crash is from. Oh, now I've really done it, huh? How about if it equals plain? Huh. I would have thought it would have stopped at that point. Let me look here. So I'm pretty sure we remove the pieces from the board as soon as they die. Let's what happens here exactly? Okay, my piece did get removed. That's right. But we still see the. Oh yeah. So yeah, it's just playing the animation because that's how we hooked up the animations. But what we could do is we could have the engine say what initiative the game ended on, basically. That probably makes the most sense. Okay, so since I'm putting this in the attack phase code, I don't actually need to do it here anymore. And then what we can do is we can just we can pass in the current initiative maybe to this function. And then basically we only need to ever do this once, right? And then when the game does end, so if we're no longer in playing, then we can also log like final initiative or something like that. That way, that'll tell us like the last one we actually need to animate. Let's have it be -1 to start. Okie doke. So that'll be the last initiative that we actually want to animate. And then over in the code that does the animation, let's have it be greater than the log's final initiative. I think that'll be what we want. For greater than or equal to what we might do, just to keep things more simple, is in here we're looking at the log, pieces of this and that. What we can do instead, we can say if the initiative is less than log.final initiative, then we'll just return false. This comment, I don't think I need this comment anymore, because that was just me a thinking comment. Okay, maybe it works now. Alright, so that cut off our animation. Let's make sure, if we don't die, it plays all the animations. So that's looking good. Alright. Pretty good. That's a decent amount of progress, I think. I finished that. So we've kind of, I think that's enough to say we've finished our initial plan there. So that's all of our initial doodads now. What we can do now is we can design more pieces. We probably want like a diagonally attacking piece. We probably want some kind of rook-like piece and a bishop-like piece. What else would we want? I mean, we could take some inspiration from shogi and have like their general type pieces that can move in a lot of different ways, similar to a king. But maybe they can have like, higher initiative. There's also the shogi lance, which could be an interesting idea. We also probably want to have like upgraded pieces. If they pass a line, get upgraded. Something like that. Yeah. This might be a pretty good place to stop for today, I think. We've kind of cleaned up a lot of stuff. We added our initiative feature. So we added the game victory condition. We made a few different improvements here. I think it'll really start getting more interesting now once I add more pieces. And it'll actually, start looking more like a game. And then we can experiment with the crazier ideas once we determine if the main game is fun or not. You know, I'd like to not make it crazy if you don't have to. So yeah, let me see if there's any other notes. I don't think there's any other notes I wanted to make about what I was doing. Yeah, I think this was some good progress. I don't know why Visual Studio Code thinks this file has problems. Yeah, I don't know why it thinks that file has problems. Alright. Well, thanks for following my game dev here. And we're gonna make it a lot more interesting later. So I hope you stick around, and I'll see you next time.